It's set. We'll talk a lot about carbon dating, radioactive dating, and how it's done. So we said Earth's about 4.6 billion years ago, or old. How do we know such things? Like, that seems like a pretty exact age. Well, what we do is we use something called absolute dating. We should know absolute means exact. We want to know exactly how old something is. And to do that, we use the property of atoms we talked about in that first video. Everything's made of atoms. We know each atom is unique based on the number of protons it has. If you have 1, you're hydrogen, 2, helium, 3, lithium, so forth. Within those, we said in the last video that neutrons can vary. They're called isotopes. So most hydrogen atoms have 0 neutrons, but some have 1, some have 2. And over time, some of these atoms can change into different atoms. Remember at the end of the last video, we talked about radioactive decay. We're going to go more into that. Sorry about that. The original atom we start with is called the parent atom. What it breaks down into through radioactive decay is the daughter atom. So half the parent atoms turn into daughter atoms once the object gets a certain age. And that object is different for every different type of element. So on your birthday, you turn a different age. Elements over time change as well. So how do scientists learn about things like the age of the Earth? Well, they count the number of parent atoms and daughter atoms, and then they compare what percentage of the atoms are parent versus daughter, and they'll see how many half-lives have passed. Some half-lives are more than 4 billion years old, others shorter, like 6,000 years, and they are able to distinguish based on the different elements. Here's one that's used sometimes. Potassium-40 has a half-life of 1.3 billion years. So if a rock is older than about 100,000 years, they use that. Uranium-238 has a half-life of 4.5 billion years, about as old as Earth. It can be used to date rocks older than 10 million years. So uranium-238 is actually what was used to date Earth. Carbon-14 has a half-life of 5,720 years. So this is really good for recent things. So radiometric dating is what we're talking about. It uses the half-life of atoms to figure out the age of rock layers and atoms in different substances. So you get an exact age. And using uranium-238, they say Earth is about 4.6 billion years old. Before they used this method, they thought the Earth was 6,000 years old. But with technology and science, they now know how old it is based on radiometric dating using uranium-238. So here's an example. Scientists know that half of the parent atoms are going to turn into daughter atoms every 10,000 years. If we started with 16 milligrams of parent atoms, in 10,000 years, we would have 8 of those. And we'd also have 8 daughter atoms. If we go another 10,000 years, we're going to have half of these breaking down. So we're going to end up with 4 parent and 12 daughter, a 1-to-3 ratio. So if we find a 1-to-3 ratio, we know that's 20,000 years. If we find a 1-to-1 ratio, we know that's 10,000 years. And then any ratios in between there, the closer it is to 1-to-1, the closer it is to 10,000 years, the closer it is to 1-to-3, the closer it would be to 20,000 years. I just said this on the last slide. Now, if another 10,000 years go by, we're going from 4, half of those go down to 2, we have to equal 16, because that's what the total is. So those 2 turn to daughter atoms, and now we're at 14. And then we'd be at 1 and 15. And then we'd be at a half and 15 and a half. Then we'd be at 0.25 and 15.75. You never get to 0 because you can always keep dividing by 2. So again, it's all about comparing the number of parent atoms to daughter atoms in a sample to see how many half-lives have gone by. So the more daughter atoms you have, the older the rock is. The more parent atoms you have, the younger the rock is. This kind of summarizes and gives you a nice visual, so you might want to look at this. But we've already said all this. Again, to show you down here, this is what we start with. This is 1 half-life, and we end up in a 1-to-1 ratio. 2 half-lives, we end up in a 1-to-3. And 3 half-lives, we end up in a 1-to-7 ratio. And again, that first number, the 1, is parent atoms, and the second number is daughter atoms. And that's a pretty good summary of how carbon and radioactive dating works.